Hello and welcome CS271 students to this video, which is going to be talking about interfaces. So to start off, I want to do a little bit of review and talk about abstract classes. You've studied that already, but here is just sort of a reminder. As you know, the world consists of objects, which are tangible things with characteristics and behavior. We're doing object-oriented programming, and so we model these objects with classes. A class is a concise description of an object. It uses instance variables to describe the characteristics of the object, and it uses methods to indicate what that object is capable of doing. An abstract class is one which cannot be instantiated, but it can define common methods that subclasses can implement. So for instance here, I have a public abstract class called animal. And you notice it has instance variables, it has a constructor, it has concrete methods, that is to say, methods that you can invoke when you need them. It also has two methods that are labeled as abstract, and you will notice that they do not have a method body. Why are they abstract? Because if I asked you to draw an animal, you can't do it. You don't know what kind of animal I'm talking about. Likewise, if I said, hey, have that animal perform some sort of activity, well, it depends on what that animal is, what sort of activity it can do. So we leave this class as abstract, and we make these methods abstract as a way of signaling that we are not yet complete. In terms of functionality, we're going to have to defer to subclasses that can figure out how to draw a particular animal or how to perform an activity for a particular animal. For instance, over here we have cat. Cat extends animal. You notice, though, that it does not have the word abstract here. That is because it has implemented the draw method and the perform activity method. If there are any other methods here that are inheritable, and indeed there are two, getter and setter, it has those methods available to it as well because it extends animal. You should remember all that from CS171. And if you tell a cat to go ahead and draw something, it will indeed go ahead and draw something, some lovely ASCII there. Just a reminder what it means to be abstract. You notice here I've got animal dinosaur equals new animal T-Rex. And then I get a squiggle. And the error is pretty obvious. Cannot instantiate the type animal. Why? Because abstract classes cannot be instantiated, even though they supply information that subclasses can use. So I'm going to go ahead and comment that out again. Now, if you are extending an abstract class, you are promising, if you're going to make a concrete class, you have to implement all of the abstract methods. So for instance, if I got rid of perform activity, we'll just comment it out here. Right away, we've got an error. The cat must implement the inherited abstract method. You can do a quick fix. Once I get to the right, let's see here, there we go. We can do generate, let's see, actually it doesn't come up with the error that I was looking for there. Try that again, quick fix. There we go, add unimplemented methods. And so it would go ahead and write this, but we've already implemented it. There we go. So we can see in all of this 4 different pillars of object-oriented programming and design. So first of all, abstraction, that's pretty obvious. We are hiding of details. When I am here in main and I tell a dog to draw itself, I'm not thinking over here about how drawing actually takes place. At some point, I might want to look at this class and see the details, but if I have, let's say, a cat, we'll have a cat here called Maurice. Maurice, who is age, I don't know how old a cat should be, we'll say 2. And if I were to say, let's see, by the way, it's complaining, what is it complaining about now? The constructor is undefined. Oh yes, name, age, and whether or not it's lactose intolerant. We'll say that it is. Okay. And then I can simply go ahead and say Maurice.draw like that. I am now using the draw method without thinking here. Well, okay, I have to think a little bit. I have to put in some numbers here. Without thinking too much about how the drawing actually takes place. That's abstraction. The next pillar is encapsulation. The fact that I have, say, a class called animal with name and age encapsulated inside this class and not actually accessible unless I use getters and setters. I have wrapped all that information into one bundle. That's encapsulation. The next pillar that we would be concerned with is inheritance. We are inheriting methods like getName and setName here in the cat subclass, and we shouldn't be ignoring our dog here, in the dog subclass as well. And finally, polymorphism. Let's take a look at our cat here. You notice that I've stored Maurice in a cat variable, and I can do that. I can also, what else could I store Maurice in? Well, a cat is a type of animal. So I could say, we'll call this Maurice the third. We'll just say Maurice third, for and false. So now I am, and of course that again, that orange, or I guess that's yellow squiggle means that I'm not doing anything with it. So I'm just going to say anim.perform activity, and we'll go for false. So once again, a cat is a type of animal. This is again is a polymorphism. To take this to extremes, just comment this out here for a moment, I've created an array list of animals, and I've added 2 animals to that array list, and now I can walk through the entire array list. It is an array list of animals. I couldn't make this dog, because if it was dog, I could only store dogs, not cats. Likewise, I couldn't make it just cat. But if I make an animal because of polymorphism, a dog is a type of animal, a cat is a type of animal, and therefore both of those objects can be stored in this array list.